In the previous video, we looked at the unit circle to figure out the coordinates of some special points. These were the points that we took. This helped us figure out the ratios for all of these angles. The coordinates gave us cos and sine for all of these angles. How did we do that? We looked at some triangles. Look at this one. This triangle is symmetric to this triangle, which means if we know the coordinates for this point, we can figure out the coordinates of this point. If we move in this direction, we have root 3 by 2, and if we move in the opposite direction, we have minus root 3 by 2. For both of these points, we are moving in the positive y direction, which is making their y coordinate the same. Using the same thing, we can figure out the coordinates for all of these other points. Alright, these are some special points. We can generalize this result using the same concept that we've used here. Let's do that. Let's have this point on this unit circle, and let's have the coordinates as green and blue. The x coordinate is green and the y coordinate is blue, which means this length is green and this length is blue. Now let's use symmetry to figure out coordinates of some other points. Let's have this one more triangle which is flipped down. What are the coordinates of this point? Think about it. If this is green and blue, this has to be green and minus blue, because we're moving down, so this is going to be green comma minus blue. What about this point? This is going to be minus green, blue, minus green comma blue. And what about this point? This is going to be minus green, minus blue, because we're moving left and we're coming down, so this is minus green and minus blue. This means if we know the values of green and blue, we can figure out the values for all of these other points as well. Let's mark the angles. If this angle is theta, this angle is minus theta. This one is pi, so this becomes pi minus theta. This becomes pi plus theta. So we have these four angles now. If we know the relationship between their coordinates, we also know the relationship between their trigonometric ratios, especially sine and cos. Let's look at them. Okay, let's look at these two first. We have theta here and minus theta here. We have green here and green here, which means the x coordinate is same. What about the y coordinate? We have blue here and minus blue here. So the y coordinates are opposite of each other. How do we use this to figure out their trigonometric ratios? The x coordinate is cos and y coordinate is sine. Cos of this point is same as cos of this point. This means cos of minus theta is same as cos of theta. It's a very useful identity. What about the sines? Blue here, minus blue here, which means sine here and minus sine here. The y coordinate of this point is negative of the y coordinate of this point. The y coordinate here is sine of minus theta. This angle is minus theta, so the y coordinate is sine of minus theta. So sine of minus theta is negative of sine of theta. So now we know the relationship between cos and sine of minus theta and theta. We can do the same for pi minus theta. Pause the video, try this on your own. What is the relationship between cos and sine of pi minus theta and cos and sine of theta? Take your time. Okay, let's do this together. Let's look at these two and look at their coordinates. X coordinate is minus green, x coordinate is green. So x coordinates are opposites. Y coordinate here is blue, y coordinate here is also blue. So they both have the same y coordinate. Now x coordinate is cos. This means the cos is negative. Cos of pi minus theta is negative of cos theta. And y coordinate is sine. This means they have the same sine. So sine of pi minus theta is same as sine of theta. So now we have the relationship between cos and sine of pi minus theta and theta. Alright, what else can we do? We can figure this point as well, pi plus theta. Let's do that. Comparing this point and our original point, pi plus theta and theta, what do we have? We have green minus green, blue minus blue. This means both sine and cos are negative of each other. Opposite x, opposite y, which means cos of pi plus theta is equal to minus cos theta. Their x coordinates are opposites. Same is the case for their y coordinates. Sine of pi plus theta is equal to minus of sine theta. Alright, what if we go full circle and come back to this point theta? What if instead of adding pi, we add 2 pi? We have the same green and same blue because we're on the same point, same x and same y. So cos of 2 pi plus theta and sine of 2 pi plus theta will be same as cos theta and sine theta. So this is how we can visually prove these 8 identities that we commonly see in textbooks. I personally don't like to call them identities. I also don't like to think about them as identities. I think they're just results that you can observe using this unit circle. Let's have a few more of them. Let's go back to our point and make this triangle again. This point has coordinates green, blue. All right. Now this time, let's flip it this way. It's lying down along the x-axis. Let's pick it up and put it along the y-axis. What are the x and y coordinates of this point? Pause the video, think about it. These two triangles are congruent. They're exactly the same. Okay. So this blue line comes here and this green line comes here. So the coordinates are flipped. The x coordinate is blue now and y coordinate is green. This point has coordinates blue, green. We started with green, blue. Now we are at blue, green. What about this triangle? What are the coordinates for this point? This length is green and this length is blue. So the coordinates are minus blue, green. Along the x-axis, we move to minus blue and along the y-axis, we move to green. What about this triangle? What are the coordinates for this point? This is blue, minus green. Blue, minus green. And what about this triangle? Well, if this is blue, minus green, this should be minus blue, minus green. All right. Now by looking at these triangles, we can generate a few more results for a few more angles. Let's do that. If this angle is theta, this angle is pi by 2 minus theta. This is 90. So this is 90 minus theta. This angle is theta. So this is pi by 2 minus theta. Using symmetry, this becomes pi by 2 plus theta. And this one is 3 pi by 2. And these two angles are theta. So this becomes 3 pi by 2 minus theta and 3 pi by 2 plus theta. So now we can compare trigonometric ratios of these angles with trigonometric ratios of theta. Let's do that. Let's pick the first quadrant first. In this quadrant, we have pi by 2 minus theta here and theta here. What's happening with their values? Well, their values have switched. Blue becomes green and green becomes blue. Which means if this is cos theta, sine theta, this becomes sine theta, cos theta. So x coordinate for this point is sine theta and y coordinate for this point is cos theta. The values have switched. What about this point? This is minus blue, green, which means the coordinates are minus sine theta and cos theta. Let's take some other point. Let's take this one. The coordinates are blue, minus green. So this makes this point sine theta, minus cos theta. And finally, let's look at this point. This is minus blue, minus green, which means the coordinates are minus sine theta and minus cos theta. Now again, these are all identities or results that I personally do not like to remember or memorize. I always plot things on the unit circle and let the symmetry give me all the answers. Let's summarize. We have these points symmetrically placed across the circle. We have these 8 points. If we know that this is theta, this is pi by 2 minus theta, this is pi by 2 plus theta, this is pi minus theta, this is pi plus theta, 3 pi by 2 minus theta, 3 pi by 2 plus theta, and this one is minus theta. So if we know the ratios for any one of them, we can figure out the ratios for all the others. If this one is green, blue, the others are some combination of green and blue with plus or minus signs, which we can figure out using symmetry. And once we have that, we have relations between cos and sine of these angles and cos theta and sine theta.